Good evening. Today we are going to see the different types of sections. In this, we are three types of sections depending upon the amount of steel. Depending upon amount of steel, we are going to classify the section as balanced, under reinforced, and over reinforced. So this under and over reinforced section we are going to say as unbalanced sections. So now that we will see, so we have balance section. So in this type of section, concrete and steel both reaches the allowable stress. Allowable stress means permissible stresses simultaneously. Means concrete and steel both are going to get permissible stresses simultaneously, and this section gives the most economical cross section and also known as critical section. This section is also known as balance section. So we have that is balance section, balanced because we are going to balance both steel and concrete in such a way that these two materials will reach maximum values simultaneously. And second, we have unbalanced section. So there are sections in which steel provided is less than the required quantity for balance sections, and these are classified into two types: under reinforced sections and over reinforced sections. Now under reinforced section, those are the sections in which steel provided is less than steel required for balance section. So that is AST balanced, and this is greater than AST under reinforced. Let us we will say UN. And second, we have these are the sections in which steel provided is more than the steel required for balance section. So in this, AST balanced less than AST over reinforced. I will say OV. So these classification depends upon the amount of steel provided. Now we will see how we are going to get this stress diagram, compressive force and tensile force in this. So now we have this section, this is balanced. Now you can say this as AST max, or we can write it as AST balanced. And whatever axis we are going to get, that axis is known as critical neutral axis. And XU, this is XU max. And then we have 0.45 FCK 37. You can see this is just above your rectangular section. This is D minus 0.42 XU max. So this is for balance section. Now when we will talk about under reinforced section, and in this, so let us we will say this steel is AST under reinforced. Now this AST under reinforced less than AST balance. So if I will say this is TU balance, then we have this as TU under reinforced. Now this TU under reinforced is less than TU balanced. As this is less than TU balance, so compressive force also reduced because we know CU under reinforced, that is equal to TU under reinforced. And as TU under reinforced is less than TU balanced, so we should have Cu under reinforced less than Cu balanced, and therefore my stress diagram is less than the stress diagram for balanced section. And then we are going to get this as, so you can see this neutral axis we are going to get, neutral axis we are going to get that will shifted upward. And why shifted upward? Because my value of xu is less than xu max. So in case of under reinforced section, neutral axis shifted upward because my Cu value in under reinforced is less than Cu value in balanced. So this I can write it as balanced. And then we are going to get this as Cu under reinforced. So we have Cu under reinforced, Tu under reinforced. And value of Mu, now in this, as steel provided is less than balanced, so steel will reaches maximum value first. Steel reaches maximum value first. As we are going to say, this area of concrete we are considering is less than this area of concrete. So my concrete material will less than the permissible stresses, less than the permissible stresses. And as steel reaches maximum value first, so we have to use Mu formula that will be 0.87 FyAST into D minus 0.42 XU. Because steel reaches maximum value first, concrete is not going to reach maximum value. And why this section is preferred? Because in this, steel reaches maximum value first, and if value increases, then our steel will bend and it will give warning before failure, because failure is of steel and steel is a ductile material. So now here you can see our Cu that also shifted upward, and then we are going to get this as Cu under reinforced gives you less than Cu balanced. Then we have second, so this we have that is again balanced section, and so this we have AST balanced. So this is for balanced section. So now in this we have all these values as maximum, and neutral axis we have critical neutral axis. Now we can see this. Now whatever here we are going to provide, so this I will say as AST or reinforced. So we have AST or reinforced, and this AST or reinforced is greater than AST balanced. So what happened due to this? TU or reinforced greater than TU balanced, and therefore Cu or reinforced greater than Cu balanced. So my stress block diagram should be greater than balanced section, and you can see this if we will draw this line. So stress block diagram having Xu value which will be greater than Xu max. So we have this value Xu greater than Xu max. And then we have concrete reaches maximum value first. And therefore, in over reinforced, concrete will fail before steel, and as concrete is brittle material, it will not give any warning. We have sudden failure if our section is over reinforced section, and therefore in limit state method over reinforced sections are not allowed. So we are not going to design over reinforced section. And when we are going to analyze, we have to take value of XU equal to XU max, because as per IS code, you cannot have value of XU greater than XU max. So this is not allowed. So not allowed, I can say. So this is not allowed. So if my section is over reinforced, then also I have to take it as XU max. And then you can see we have this balanced section summary. If I will say, then in balanced we have concrete allowable stresses, we have steel also allowable stresses. Under reinforced we have steel allowable stresses, but stress in concrete is less than allowable stress. In over reinforced concrete we reaches allowable stresses, but still we have less than the allowable stresses. So we are with this uh, summary of this, and then we are going to prepare a table in which we are going to consider these three criterias. So neutral axis balance section, we are going to say XU equal to XU max, and this is also known as critical neutral axis. Under reinforced you have XU less than XU max, means my neutral axis shifted upward. In over reinforced XU greater than XU max, my neutral axis shifted downward. Now area of steel, we have AST max, or you can write it as AST balanced. Then under reinforced, we have AST less than AST max, or AST less than AST balanced, and AST greater than AST max, or we can write it as AST balanced. Now moment of resistance, as here both reaches maximum value, so we can use formula for concrete or formula for steel in balance section. In under reinforced section, steel reaches maximum value first, so I have to use moment of resistance formula of steel. And in case of over reinforced, we have concrete reaches maximum value first, so we are going to use formula of concrete. So keep in mind, these sections are not allowed. That is over reinforced section in limit state method. So this is all about your different types of section, and now we will stop here only. Thank you.